I think we ran into a similar issue during the physical lecture as well, where I had made an erroneous specifications with regards to the pivot point is, and in this case, I think I have forgotten to save or apply the changes after I made the specifications in the rigid body transform. As I can see, the centroid is fixed. That should not be what's fixed. So I go to the rigid body transform, and yes, I'm quite correct. The translation hasn't been applied, even though I quite remember I made the changes. I remember discussing this with you in the video. Yes, changes have been there, but I haven't applied them. And I'll check the motor as well. Everything's fine. And I have made a mistake over here. It should be micro Henry as I can remember. Right. So I have made two changes, and I'm running the system again. So now this should work. The graphical visualization show gives positive results, and let's see what the scope says. And yes, it starts from 30 and it's ends at 87, which is almost at 99% similar to what we obtained in previous lectures. Right, so that's kind of the advantages having benchmark simulations that you can compare your results with, so that we have such results from a source that you know is credible or is if those results have been obtained through some process you are confident in, then you can compare the results of the current model that you are working on with your previous results and figure out whether you're on the correct path or not. So that's kind of what you have to do when you are in the learning phase. And even when you go to complex systems, that would be quite a tool which would come in handy. So this is a visualization of our model, the results of our simulation, and it's only possible since we used Simscape multibody to model the revolute joint, the rod, and gravity. And of course, read through motor sizing. I have mentioned what it is on multiple occasions. For the slides to be comprehensive, I have kept this slides from last lecture as well. But I won't go into detail with regards to motor sizing once again. Right. So now that kind of concludes our work with regards to modeling a simple mechatronic system of a rod connected to a motor. We began with a differential equation, and now we have ended up with some graphical implementation of a model with zero mathematic expressions visible. None of it is visible, but of course, these expressions are hidden from us, and behind the curtains, these expressions still exist. Okay, so that concludes Simscape multibody. If you want to learn more about So what I have just taught is around 0.1% of what you can learn and what you can do with Simscape multi-body. It's a vast area, just like SolidWorks and so on. The only way you can learn is by doing, just by doing and nothing else. Okay, so I think we can conclude the lecture. I will upload the Simulink file for this particular model, but before you open that model, I suggest you go through my videos and the lecture slides and try to implement it on your own, and open and check it against the model that I provide only if you run into an issue that you can figure out. Right. If you run into any other doubts or questions, contact me and raise your questions. Right, so that's it. So I'll wind up lecture number 7. We'll go through these slides once again. Since I have described them in the physical lecture, I'm not going to go into detail now. That's it. Have a nice night.